All right, so this is the other side of our notes. The first term at the very top is supplementary. Supplementary means that the two angles add to 180 degrees. Okay, we are going to be looking at relationships today that add to 180. Yesterday we talked about relationships that are just equal to each other. If you have a highlighter, I suggest that you get out and use that. It's going to be a little helpful. If you need one, I have some for you. Okay, so we're going to start with this one that says same side interior. So same side interior. If it says interior, that means in between the two parallel lines. So that's between these two lines here. So that's where I would highlight. Okay, so we're only talking about angles 3, 4, 5, and 6. Now, if they're on the same side, we're talking about the same side of the transversal. The transversal is this one that I'm coloring in orange. So which ones are on the same side as the transversal? Angle 3 and angle 5. So angle 3 and angle 5 will add to 180. But also, if you look on the other side of the transversal on the right-hand side, angle 4 and angle 6 also fulfill that. So we have two pairs of same side interior angles. All right, the one next to it, same side exterior. Okay, if we are saying exterior, where is that located?
The outside.
On the outside of the parallel lines. So that would be angle 1 and 2 and angle 8 and 7. Okay, and on the same side as each other in regards of the transversal. So angle 1 and angle what? 8. And then angle 2 and angle 7 also are 180. Okay, now we have another set of angles called a linear pair. What does linear mean to us? Straight line. So they need to be on a straight line together, right? Okay, so linear pair angles. So what is on the same straight line as angle 1?
4.
Okay, angle 4. And there's another one that is with angle 1.
2.
Angle 2. So you see angle 1 and 2 are on this straight line, and angle 1 and 4 are on this straight line. So there's two different types of pairs there with angle 1. What's another set of linear pair angles with angle 5?
8 and 6.
5 and 8, and 5 and 6. And there's more than that, right? We could say 3 and 4, 3 and 2, 7 and 8, 7 and 6. 6 and 5, 6 and 7, and so on, just as long as they are neighbors to each other sitting on the same straight line. Okay? For this one, you only need to know how many angles to know all of them. You only need to know one of them. Because if you know one of them, you know what the other angle is, right? And there's only two different measures when we're talking about intersecting lines. So for this one, they're telling us that angle 1 is 120 degrees. That's this one. So what are the other angles, or what is another angle at that intersection that is also 120 degrees?
4.
angle 3. What is their relationship that you know that it's 120? They're vertical angles. And I heard somebody say, well, angle 5, that's at the other intersection. How do we know that angle 5? Yeah, 5 corresponds to 1. And then how do we know 7?
It corresponds to 3.
Okay, it corresponds to 3 and it's vertical to 5, right? So there's more than one way to tell. Okay, and then what about the other angles?
180, it'll be 60.
It would be 60 because we would take 180 minus 120, right? And so all of the other angles will be 60 degrees. So we have 4 of the 120, and then we have 4 of the 60s. There should be 4 of each. Yes.
How do you tell, like, what the angles are? Like, I know the 1 and the 3 are supposed to be vertical angles, but how do you tell with the numbers?
Well, they told us the angle 1 was 120.
Yeah,
So we found the other one because we took 180 minus 120. Because a straight angle, a straight line is 180 degrees. So like we know that angle 1 and angle 2 are what we call a linear pair. And so together they should add to 180. So if I know that angle 1 is 120, I take 180 minus 120 and I know that 2 is 60. All right, so look at this example to the side. Okay, they're asking us what is the value of x. First of all, what's this relationship?
180.
Is it same side interior, same side exterior, or a linear pair?
Same exit.
Linear pair. Okay, so they add to 180, so we know that 130 plus x equals 180. If we were to solve this, we would just take 130 out of 80, and x is equal to what? And that's why we're working on solving equations. Right now they're pretty simple, but they do get more complex. Okay, the example below it. What is the value of x? And then what is the measure of angle ABC? The measure of angle ABC is the ABC, that's this angle here, which is just 2x, right? So they want us to solve for x first and then tell them what 2x is equal to. Okay, this is a really bad example that we have to change because we can tell that this is not 90 degrees. So change that 90 into an 80 for me. That's going to be a little better. Okay, so what type of angles are these? What's their relationship to each other? Same side, exterior. Because they're both on the outside of those parallel lines. So here's the inside of the parallel line, so both on the outside of it. And they're both on the same side as the transversal. So that means that they're going to add to 180. So 2x plus 80 equals 180. We're going to take that 80 out. And then 2x equals 100. Then divide by 2 and x equals 50. So put 50 up there next to answer that question. And then to find the measure of angle ABC, we put 50 in for x and solve. So what's 50 times 2? And so make sure that you show that it's 100. Last one. So they're asking us the value of x and the measure of angle MKP. Okay, so this angle and this angle. Okay, they are supposed to add to 180, but how do I know that the angle next to 5x is 125? It's because this angle here corresponds with the angle above it on the other intersection. So 125 corresponds with the angle next to 5x. And that would make them a linear pair. So now subtract 125 out of 180. 5x equals 55. Divide by 5, and x is equal to 11. So answer that question next to it. And now they're asking us what is the measure of MKP. That's this angle here. See, MKP. So what is 5 times 11? So it's 55 degrees.